Okay, almost picking up where we left off last time here in section 3. Let's try another problem here. I don't know, see if we're on the right track here. Let's say something like the cosine of 5 pi over 4. Okay, so one of the first things that you need to do is identify which quadrant we're in. So for 5 pi over 4 should put us in what quadrant? Okay, nobody said 7, so I guess that's just not sure where the hesitation is coming here. Say again, Drew. Quadrant 3. Again, forget about the pi for just a moment. 5/4, so 1 1/4. So just a little bit more than 1 pi. Again, the dividing line between the second and the third quadrant is 1 pi. The dividing line between the third and the fourth would be 3 pi over 2, 1.5 pi. So this is 1.25 pi. This is in quadrant number 3. Okay? Since we are in quadrant number 3, we're going to need a reference angle that goes back to quadrant 1. And again, things we talked about last time. We're going to take, since it is quadrant 3, 5 pi over 4, and we're going to subtract pi from that. Well, again, we would need that whole common denominator thing, so 1 pi would be 4 pi over 4, giving us a reference angle of 1 pi over 4. Very good. Now, let's consider positive or negative. In the third quadrant, all students take calculus. Should cosine be positive or negative? It should be negative. So we could say that the cosine of 5 pi over 4 is the same thing as the negative of the cosine of 1 pi over 4. I'm hoping at some point in time, in the extremely near future, rather than the distant future, that as you come in, you not only get out your surfaces, but you also take out the calculator, and at this moment in time, most importantly, where's that note card? Shuffle, 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 dig through my book bag, trying to find the calculator. From your note card, what is the value of the cosine of pi over 4? So we should be able to say that the cosine of 5 pi over 4 is negative square root of 2 over 2. Got that? Any questions, any problems, any issues? It's like one of those court proceedings. Speak now or forever. All right, so I do believe this is where we put things on pause last time. Trigonometric identities. These are formulas that you should know. Statements showing a relationship between trigonometric functions that are absolutely 100% of the time have to be completely true. Okay. Again, now some of these you may already have on your note card, especially the reciprocals, that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. And again, remember when you're matching those up of those terms, in each pair, only one of them is going to have that prefix co. Okay, that cosecant does not match up with cosine. Got it? Yes, no, maybe, kind of, sort of?
Yeah.
Sure. Heard that before. All right. Now again, if we're using our lovely trigonometric function definitions here, we should know that the sine is y over r, that the cosine is x over r, and that tangent, oh, I guess, sorry, shouldn't be using that. I hate using t. And tangent is y over x. Now we got to do a little bit of lovely manipulation here. Is the sine function associated with the x coordinate or the y coordinate? And I wrote something on the board already. Is the sine function related to the x coordinate or the y coordinate? The y coordinate. Cosine is related to the x coordinate. And again, both of them involve the length of the radius there. Okay. We could, I guess, oh, I know how much you guys love fractions. We could say that the y coordinate is always going to be r times the sine of theta. We could say that the x coordinate is going to be r times the cosine of theta. Which means the tangent, if we do a little bit of substitution here, is r sine theta divided by r cosine theta. But wait, there's more. We could reduce and say that the tangent of theta should be equal to sine divided by cosine. That's an extremely useful trigonometric identity. For any angle whatsoever. From your note card, what's the tangent? I'm sorry, what's the sine of pi over 4? What's the cosine of pi over 4? Square root of 2 over 2. Really? You're too lazy to say square root of 2 over 2? Don't fold it at a square. Wait a minute. Square root of 2 over 2 divided by square root of 2 over 2 should be equal to, what's it say on your note card for the tangent of 45 degrees? It's 1. Okay? Possibly the most famous theorem of all of mathematics. Thanks to dear old Pythagoras, we know the sum of the squares of the lengths of the two legs of a right triangle is equal to the square of the length of the hypotenuse. Please tell me that Pythagorean equation looks familiar. They even said please. Okay, you're not in a joking mood today. Got it. Come on. Little cooperation here. There we go. But now we've taken that right triangle here to try and put it in terms of our trigonometric functions. And what did we just a moment ago say that x was? X is r cosine theta. So I could do that little substitution and say that this is r cosine theta squared. Y, we said just a moment ago, was r sine theta. So I could make those little substitutions. Using our rules for exponents, inside each of those sets of parentheses, I have a product. So I need to take each of those factors inside the parentheses and raise each of them to that same exponent. So this is r squared cosine squared plus r squared sine squared is equal to r squared. So far, so good? Equation seems rather redundant, doesn't it? R squared is a factor in all three terms, including that lonely one over there on the right-hand side. So we could go through and divide absolutely everything here. Now, I'm going to mess around with the order here just a little bit. Addition is commutative, so This gives us the first of our Pythagorean identities. And hopefully we understand here it's called a Pythagorean identity because we got this from the Pythagorean theorem. Okay? We're applying our definitions here of the trigonometric functions to the Pythagorean theorem, and every single time, doesn't matter what the angle measure is, if we take the sine of that angle and square it, we take the cosine of that same angle and square it, add those two together, the sum will be equal to 1. We got it? This is going to be, I hope, one of the first of these trigonometric identities that you memorize. And I think you're going to remember it simply by usage. I don't think you're going to have to take much time to sit down and stare at it and then close your eyes and try and repeat it. You know, we're going to use this one so often, hopefully it will become familiar. Now, as mathematicians, we play around with stuff. What happens if I take that basic Pythagorean identity and I divide by sine squared? Well, sine squared divided by sine squared should be 1. Okay, that was not a trick question. And now I have cosine squared divided by sine squared. Oh, wait a minute. Just a moment ago, we said that tangent was sine divided by cosine. And now we have cosine squared divided by sine squared. Well, if you forget about the exponents for a moment, just for a moment, I promise. If tangent can also be defined as sine divided by cosine, here I've got cosine divided by sine. It seems to be the reciprocal. So that should be equal to cotangent. But now, since it's cosine squared and sine squared, this will be equal to cotangent squared. And then that lonely term on the right there is 1 over sine squared. Boy, what's 1 over sine? 1 over sine, what's the reciprocal there? Cosecant, so 1 over sine squared is cosecant squared. Isn't that fun? This is another Pythagorean identity. So if we came up with another one by taking that original Pythagorean identity and dividing everything by sine, we could get another one if we divided everything by cosine. Well, actually, more to the point, cosine squared. What's sine divided by cosine? What's sine divided by cosine equal? Tangent. So sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared is 1. And 1 over cosine squared is secant squared. So those three are listed on the notes that I sent you there through OneNote as Pythagorean identities. Yes, those are permitted for the back of your note card. So you may want to put that on there later, as in not now. And this thing just has a mind of its own. And again, it would be a really good habit if you started reading the title of the slides here. Our challenge now that we know a few of our trigonometric identities is being able to express one trigonometric function in terms of another one. So for part A here, they're asking us to express sine of theta in terms of the function cosine. Oh, we might as well just go over here and do it. Well, we have, again, our basic Pythagorean identity that sine squared plus cosine squared is equal to 1. There's an identity that tells us a relationship between the sine and cosine functions. But again, the directions here asked us to write out sine in terms of cosine. So that means I need to take this equation here that we learned through trigonometry and now use my algebra skills to solve it for sine. Okay? So I need to get that isolated. I'm going to subtract cosine squared from both sides and say that sine squared theta is equal to 1 minus cosine squared theta. So far, so good? 2 or 3 head nods, the rest of you just floating in limbo. But again, we want to know what sine is equal to, not sine squared. What are we going to do? We're going to take the square root of both sides. So when we take the square root of both sides, we're going to get how many answers? So we could say that the sine of theta is equal to plus or minus the square root of 1 minus cosine squared. So that's the expression that you would write. Questions on that? Now notice here how for part B, the directions changed subtly. So they're asking us to do kind of the same thing again, express one function in terms of another one, but this time they gave us some additional information. So we're supposed to express tangent in terms of sine. Well, of the very, very short list of Pythagorean trigonometric identities that we have, just about the only one that relates tangent and sine is our little expression here that tangent is equal to sine divided by cosine. And that's not exactly what we were supposed to do here. We're supposed to express tangent in terms of just the sine function, not a combination of sine and cosine. So we're going to have to do a little bit of a substitution here and get rid of cosine. Any ideas? Now, if we've just worked this out from the previous part, where sine of theta is equal to plus or minus the square root of 1 minus cosine squared, we could pretty much reverse that process and say that cosine theta is plus or minus the square root of 1 minus sine squared. Again, that substitution here for part B is not so obvious had we not done part A. Should I do part A? We good? All right. I'm hoping all of you are keeping up with Jay back here, because he's just about the only one who's giving me any kind of a even non-verbal response to these things. Now, if Jay's giving me non-verbal responses to my questions, can I still refer to him as the class spokesman? Because he's not speaking technically. That was a rhetorical question. This is not an official position, nor have you been elected, nor are you going to have that position permanently. But, you know, sounds like some of you here are unfortunately going to end up being typical American adults and not vote when you have the opportunity. Anyway, there's one additional thing here. We've got to revise. We were told that theta is in quadrant number 2. And I've done that substitution there for cosine is plus or minus the square root of 1 minus sine squared. Give it some thought. If theta is in quadrant number 2, should the cosine be positive or negative? So I shouldn't have plus or minus. I know because they told us I'm in quadrant number 2 that the cosine should be the negative square root of 1 minus sine squared. Does that make sense? Okay. And then if we take a look at this expression here, in the second quadrant, should sine be positive or negative? That should be positive. And we've established in quadrant 2, cosine should be negative. So we've got a ratio here of positive divided by negative. Should that value be positive or negative? Obviously negative. In quadrant number 2, this is supposed to be an expression here for tangent. Is tangent in the second quadrant supposed to be positive or negative? Negative. Hey, look, it matches up. So again, compare and contrast there. For the first part, they just said express sine in terms of cosine. So we had to have that in the rather generic plus or minus, because the sign depends upon what quadrant we're in. But for part B, they were specific, telling us that theta was in quadrant number 2. Come on. So that's why we can specify there and say that it's sine over the negative square root. Any questions on that? All right, one last thing. How do you find area of a triangle? 1/2 times base times height. And of course, you remember very distinctly from geometry class, base and height have to be two segments that are perpendicular. What happens if you don't have things that are perpendicular? Well, in geometry class, then we struggled with putting in an altitude so we could find the length of something that was perpendicular. Okay? So from one vertex, we dropped down that altitude so it was perpendicular to the opposite side. And then that split segment A somehow, okay, depended upon that angle, depended upon the other side lengths there. But now from the standpoint of trigonometry, suppose we know the measurement of angle theta. Take a look at it. Look at the board. Look at the look at the wall. Look at the image that is being projected. That just does not roll off the tongue, does it? Using theta as our reference angle, the height of the triangle H, is that the leg opposite, leg adjacent, or hypotenuse? Leg opposite. And we've split side A, so I'm not so sure about that. But I haven't done anything to mess around with side B. Is that the leg opposite, leg adjacent, or hypotenuse? It's the hypotenuse. If I put in this as an altitude, that should be a 90-degree angle right there. So then side B turns out to be the hypotenuse. What function relates? The leg opposite and the hypotenuse? Sine. Dun, dun, dun. So the height, H, becomes B times the sine of theta. And a little substitution there gives us our new area formula for a triangle. This one you have to memorize. This one does not go on the note card. We can find the area of a triangle without base and height. We can find area of a triangle if we know the length of two sides of the triangle and the measure of the included angle. You guys remember side, 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 angle, side, angle, side, angle? Remember all those? We need to know the included angle. If it's angle side side, we know that never works. Again, why is it? So let's take a look at this. We have ourselves a very obtuse triangle ABC. We're given the length of segment AB is 10 centimeters. We're given the length of segment BC is 3 centimeters. And we know the included angle there, angle B, is 120 degrees. Don't need no stinking altitude here. We can simply put that into our new formula where it's 1/2 A times B times sine of theta. Well, one side of the triangle is 10, another side of the triangle is 3. The included angle measure is 120 degrees. Wait a minute. All right, now let's put this in context of what we've been talking about in this section. 120 degrees is in which quadrant? And in quadrant number 2, should the sign be positive or negative? Come on, all students take calculus. You got that lovely little mnemonic to help you. It should be positive. All right, so second quadrant, our reference angle, 180 minus 120 should give us 60 degrees. So the sine of 120 degrees is the same value as the sine of 60 degrees. 1/2 times 10 times 3, that'll give you 15. 15, well, the sine of 60 degrees is square root of 3 over 2. You got that in your note card, right? So then if we wanted a decimal approximation there, 15 times the square root of 3 divided by 2 will give us somewhere around 13. Now again, the side lengths were given in centimeters. The area here should be in square centimeters. Because we remember, area is 2-dimensional. And I drilled that into your head that you're supposed to pay attention to dimension. I don't rhyme all the time. Pay attention when I do. Okay, I believe that wraps up everything that we need to talk about here in section 3. If you take a look at what you have on OneNote, find the assignment page that I sent to you earlier. And this will be due, oh goodness, do we actually have to come to school on Monday? So this will be due on Monday the 14th. Any questions there? All right, ready, set, go. Good one, Adam, good one.